Welcome to this NX help tip. In part 3, we're going to look at how you can use attributes for your templates. Technical drawings will normally contain text to provide information the views and dimensions can't. You can just write everything manually, but why be less productive when you can use attributes to speed up the process? First thing we'll look at are the system attributes. There are 11 of them designed to provide basic information about the drawing. For this example, I've just pasted the content from the text file. The example shows the sheet number and number of sheets, revision letter of the drawing sheet, the sheet scale and sheet size, drawing units, projection angle, model file name and drawing file name. All of these are updated as changes are made to the sheets. If we add a new sheet to the drawing, the number of sheets in the file increases to 2. Add another sheet and it goes to 3. If we take the note and paste it to sheet 2, the note will change to show sheet 2 of 3. Paste the note back to sheet 1 and it shows sheet 1 of 3. If we edit the revision letter, it will update. Change the sheet scale and again it updates. Changing the size of the sheet will update to A4 and of course the border, as described in video number 2, changes to suit as well. If we change the units and we also want first angle projection, then we get inches and the projection symbol will update. Because we're using the master model method, we can see the model file name and then the drawing file name will match. If we make some changes to the text in the note, you can see the text changes, but the system attribute values stay as they are. To get the full list of these, open up the NX documentation. Go to CAD, Drafting, Drawing Automation, Adding Attributes to Drawing Templates, System Attributes for Drawing Templates. Here you will have the full list of 11 system attributes. The control string is what is needed in your note. For this example, we'll copy the text directly. Paste it into a note, edit the text to clean up the formatting. And then we have the attribute values along with the descriptions. If we compare the help to the note, you can see the control strings that are used and the subsequent values they contain. If you look at the last line, you can see the sheet zone is showing as C3. The position that is used for the zone is the alignment position of the note. If we edit the settings for the note and change the alignment to bottom left, the attribute will update. Move the note around and it updates to suit the zone it is in. commonly asked question is how we can use information from models on a drawing. Mass and material are a good example of what's asked for. Simplest way is to create a new note. Then add a relationship, select Insert Object Attribute, pick the component in the navigator, pick the attribute to link to, and the reference will be created. We can do the same for material. Since this video is about templates, we'll demonstrate a way to use the model attributes in your drawing templates. First, I'm going to add a description to my model part by adding a new attribute. I now want to assign a material to the model. This will give the model a density that can be used for mass calculation. If we look at the weight properties of the part, the mass is out of date. Click on the refresh, we'll update the part mass. Switch back to attributes and then apply to create the mass attribute mass prop mass. Because the part was set to update weight on save, this would happen automatically if the part was saved. We now open the drawing template and enter File, Utilities, Attribute Templates. The attributes must be created in the part file. Assigning a category is not necessary, but it makes it easier to find them when scrolling the lists. Any attribute that you want to link to a model part must start with db_dwg_template_ followed by the name of the attribute in the part file. The db_dwg_template tells NX that the attribute is to be linked to the named attribute in the model part file. In this example, I want to link to the attribute I created for the description. And to the mass prop mass 1 for the mass value. Now we add a note to the drawing, linked to the two attributes just created. We use Insert Part Attribute in this case because they exist in the drawing part file. We have a problem as the description text is showing the attribute name, but mass prop mass isn't. If we save the part, then create a new drawing based on this template, we can see the description we added to the model is displayed but not the mass. If we edit the part attribute for the description, the node updates. Notice, however, that the mass is not displayed. You can't link directly to the system-created attributes like mass prop mass. However, there is a method to get it to work. Open the model again. Then create a new string attribute. Click on Reference Text, then select Mass Prop Mass. You will now have a new attribute that references the value of mass prop mass. If you look in the expression editor, you can see two new expressions. One links to the mass prop mass attribute. The other sets the new attribute with the value from the previous expression. You can change the number of decimal places by editing the formula. We can also convert from kilos to grams by multiplying the expression by 1000. Checking the attributes, we can see the value is now set and in grams. Now we need to edit our template file. Again, go into the attribute templates. Delete the non-working one from the previous example. Now we can create two attributes to link to the mass one we just created in the model and the material attribute. We can now add a note that references the three attributes. Notice that now all three show the proper attribute name. This is a good indicator that your note will work and update properly. Open the model file. Create a new drawing based on the template. You can see that all three attributes have the correct values from the model. As before, if we edit the description attribute in the part, the drawing node updates. We can change the material for the model, make sure the weight is updated by either refreshing or saving the model. Check the drawing and the material and mass are now updated to match the model.